This video will cover customizing layers in ggplot visualizations. By the end of this video, you should understand which components of a layer are controlled by aesthetics, how you can determine the aesthetics required or accepted by a given geometry, what components of a layer are controlled by layer properties, and how you can determine the layer properties accepted by a geometry. The code used in this video is available in the Learning Management System. We're going to use the Iris dataset, which is built into R. So you should already be somewhat familiar with aesthetics from previous videos. But remember, aesthetics change the appearance of your graph. Every geometry in ggplot takes a mapping equals AES function, and inside the parentheses, you're going to put various aesthetics of the visualization. You're going to use aesthetics to describe the variables the graph should use, and how to group and display data. Remember, all the aesthetics go inside this AES function. So in this example we've seen before, I'm setting the X aesthetic equal to sepal length. That's going to set the values used on the X-axis. I'm setting the Y aesthetic equal to sepal width. That's going to set the values used on the Y-axis. And then I'm setting the color aesthetic equal to the species column of my data. This is going to color code all the points in my visualization, one color for each value of the species variable. Not every aesthetic makes sense for every geometry. So each geometry is going to take its own set of aesthetics. For example, geom_point can take things that specify the dot color, the size, and the shape. Geom_line has aesthetics for things like the line width and the pattern of the line. Typing help with the geometry name can show you the set of valid aesthetics for that geometry. A nice feature of ggplot is that aesthetic names are common across all the geometries. So you're always going to specify the data on the x-axis using the x aesthetic. Likewise, data on the y-axis will be specified using the y aesthetic. You'll set the color using the color aesthetic. When you have shapes that require filling, you can set the fill color using the fill aesthetic. And you can use the size aesthetic to change the size of lines or points. These are just a subset of the aesthetics, but remember, the terms used will be common across all of the geometries. What each of these terms mean can be a little complicated. There's an excellent help file in the ggplot2 specs vignette. Just type that command in my slides into the R console, and it will provide a help file that describes each aesthetic in detail. Again, a nice thing about ggplot is you only need to learn an aesthetic once. Every geometry that uses a color aesthetic implements it in the exact same way. So learning how to use it for geom_point will allow you to use it with any other geometry that accepts the color aesthetic. It's important to understand how aesthetics work in ggplot. Remember that aesthetics will always interact with your data to create the visualization. So for example, the color aesthetic is going to color code the data in your visualization according to the value of a variable. Likewise, the size aesthetic will change the size of points in your visualization corresponding to the value of a variable that you specify. Let's take a look at some visualization aesthetics in RStudio. First, I'll run my setup code to make sure I have the tidyverse loaded. I want to go back to the first visualization that we've created in this class. Again, it's just a point geometry of the Iris dataset. We'll use this as a basis of comparison. So I've created that visualization. It's shown up in the viewer window. We might think about using the color aesthetic with this visualization. So again, the way that I do that is I add an additional argument to the AES function where I say color is equal to species. What this is going to do is color code every dot in the visualization depending on the value of the species variable. So I'll take that code and run it. Let's take a look at the output. And you can see in my visualization, there are now 3 different colors of points. Each one corresponds to a value in the newly added species legend. Otherwise, the graph is the same. So the species variable is a categorical variable. It's just some text listing out the species. You can also color code by a numeric variable. In this case, R is going to create a continuous color scale instead of a discrete color scale. So here in this sample code, instead of specifying species with the color aesthetic, I'm going to specify petal width, which is a numeric variable in the Iris dataset. I'll run that code. And now you can see in this new visualization, the dots are color coded from dark blue to light blue. The legend on the right-hand side shows the petal width scale, ranging from 0 all the way up to 2.5. Again, remembering all of the aesthetics can be difficult for a given geometry. The help files that are included with ggplot are excellent. If you'd like to know the aesthetics that are associated with geom_point, you can just type help with geom_point in quotation marks. I'll do that here. And you can see over in the viewer, the help file for geom_point has opened up. It provides detailed information on the geom_point geometry. As you scroll down, you see there's a section called aesthetics, and it tells you each of the aesthetics that are available to geom_point. The meanings of these aesthetic names are consistent across every geometry used by ggplot, but if you need to know what they mean, you can just read the vignette for ggplot specs, You do that by typing vignette with ggplot2-specs in quotation marks. I'll do that now. You can see this opens up a new help file called Aesthetic Specifications. It describes every possible aesthetic for ggplot geometries and tells you how to specify the arguments for them. So as one more example, instead of using the color aesthetic to represent different values of a variable, you might want to use the dot size instead, using the size aesthetic. So what I have here, I've changed the geom point aesthetics, so now the size aesthetic is set to petal width. Take this code, run it, and then take a look at the resulting visualization, and you can see now the size of each point varies, again depending on the value of petal width. This is the important thing to remember about aesthetics. They're always going to interact with your data and create portions of your visualization that change depending on values of variables that are in your data set. You'll remember that geometries also accept layer properties. In contrast to aesthetics, layer properties control the overall appearance of a layer. For example, you would use a layer property to change the color of every point in your scatter plot, or to change the size of every point in your scatter plot. Likewise, you might use a layer property to change the thickness of every line in a graph. Layer properties are set outside of the aesthetic function. So in this example here, I have the aesthetic function setting the x and y aesthetics, but then outside of it, I set the color equal to a piece of text that says red. What this is going to do is make every point in this geometry red. Like aesthetics, layer properties are always going to have a property equals value pair. If the value is text, it needs to be included in quotation marks. So in the example I just showed you, I wanted the text red to specify the color of each dot. I need to include that inside quotation marks. Many layer properties have names that are identical to aesthetics. This is to help make it easy for you to remember how to change the properties of a given layer. But remember, layer properties apply to all data in that layer. So setting the color layer property is going to change the color of all the dots in your scatter plot, whereas setting the color aesthetic would color code dots based on the data in your tibble. Additionally, layer property values are always single values, not columns in your tibble. So for example, you'll set color equal to blue as opposed to color equal to and then the name of a variable in your tibble. So let's adjust the layer properties with some geometries. In this first example that I have here, I'm setting the size layer property on this point geometry to 4. I'll run that bit of code. We can look at the resulting visualization. And as you can see, compared to the visualizations we've made in the past, the dots are much larger than they were before, but they're all the same size. This is the distinction between an aesthetic and a layer property. The layer properties are going to make uniform changes to every piece of geometry, whereas aesthetics will vary by some piece of information in your data. I can also use layer properties to do things like set the color. So in this example here, I've set the color layer property to blue. Blue is text, so I need to include it in quotes. This is going to make every dot in the visualization blue. Again, I'll run this piece of code. Let's take a look at the resulting visualization. And as you can see, the color of every dot is now blue. I've used the word blue to indicate what color I would like. R knows a few hundred different color names. If you're not sure what they are, you can get a listing of them by typing in colors with parentheses after it. R will then print out a list of all the color names that it knows in the output window. I'll run that, and as you can see in the output window, there are a lot of different color names. I hope the color that you want is in there somewhere. You can combine aesthetics and layer properties. So I have another example here where I take that same point geometry. I'm setting the color aesthetic equal to species, but I'm setting the layer property size equal to 6. What this is going to do is draw dots of uniform size as specified by 6, but it's going to color code each of those dots according to values of the species variable. Let's run that code and take a look at the visualization. And as you can see, we get what we expected. Dots are color-coded by species because they were set as an aesthetic, but they're all of a uniform size, which is bigger than normal because I set the size layer property. You can combine layers, layer properties, and aesthetics in interesting ways. So I have some sample code here. It's going to draw a couple of layers, and it's important to think about what we're going to get out of this. So the first layer is a geom point layer. I set the color aesthetic equal to species and the size equal to 6. This is going to draw rather large dots that are color-coded by the value of the species variable. The second layer that I have here is again a point geometry. I've set the color layer property to black and the size equal to 4. This is going to draw smaller black dots on every one of the data points. So what we should get out of this is a visualization where there are color-coded data points that kind of look like bullseyes with a ring of color on the outside, but then part of it will be covered up by the smaller black dot that's drawn on the same point. So let's run this code. And now take a look at what we have. Again, the rings are color-coded by the values of the species variable. There are black dots covering up the center of each point. Again, this is just one creative application of how you might combine layers, layer properties, and aesthetics.